Okay, so we are to Unit 3, Lesson 5, and this is starting the second half of this unit. So we have 3 more lessons in this unit till our next quiz. So this lesson is about compound inequalities. So we're going to write and graph compound inequalities, solve them, and use them to solve some real-life problems. So in our first example, we're going to be just focusing on writing and graphing compound inequalities. So in example 1, part A, it says a number x is greater than -8 and less than or equal to 4. So this is an and inequality, and this is how I'd write it. -8 on the left, and -8 is less than x, because it says x is greater than -8. So if I read it in terms of x, x is greater than -8. And then x is less than or equal to 4. So less than or equal to 4. So that's how you write an and inequality. The lesser number on the left, the greater number on the right, the variable in the middle. To graph this inequality, I'm just going to use 2 points just to show how to graph. So this would be an open circle at -8 and a closed circle at +4. And since our value is greater than -8 and less than or equal to 4, in this case, I would shade to the middle. I would shade in between the two, because it's less than or equal to 4, but still greater than -8. So in the next part, we're going to write and graph an OR inequality. So an OR inequality is a little bit easier. We just have to write 2 separate inequalities separated by OR. So a number y is at most 0. That means if it is at most 0, it is less than or equal to 0. Or it is at least 2, that means it has to be greater than or equal to 2. So it's important to know the difference between at most and at least, and that's why I included this example. So in this inequality, 0 with a closed circle, 2 with a closed circle, and in this case, I shade to the left of 0 and to the right of 2. So to the left of 0 and to the right of 2. Just follow what the inequalities say. You do them separately. So I've got some guided practice, a couple examples for you to go through on your own. Good chance for you to pause the video and try these on your own, and then check your solutions or your answers with me. Okay, so for these 2 guided practice problems, I've got an AND inequality first, then an OR inequality. So an AND inequality, this means all numbers between 0 and 10. So all numbers between 0 and 10. So closed circles, I shade in between them. Here, it says a number is fewer than -6, or it is greater than or equal to -3. No less than is greater than or equal to. So I'd shade to the left of -6, to the right of -3. So moving ahead, solving compound inequalities with AND. Here we actually have 2 inequalities written, and we are going to solve these 2 inequalities and then put them back together into an AND inequality. So the best way I would say to write this is to write these as 2 separate inequalities. -4 is less than x minus 2, and then x minus 2 is less than 3. So to solve this, I would add 2 to both sides. This would be -2 is less than x. Oh, why did I write 2? Less than x. And then with the other inequality, I would add 2. X is less than 5. So to rewrite this as a single AND inequality would look like this. -2 is less than x. X is less than 5. So it's kind of like I pull them apart to solve them and then bring them back together once I have my solutions. So the solution to this would be -2, +5, open circles at both, and I would shade in between them. So in this next part of the example, I'm going to write these as 2 separate inequalities. -3 is less than -2x plus 1, and then negative 2x plus 1 is less than or equal to 9. So I'm going to solve these separately and then put them back together. So first I would subtract 1. This is negative 4 is less than negative 2x. Now I'll finish solving this by dividing by negative 2. And this is a big deal. We have to remember, I divided both sides by a negative value. So this is going to be 2 is greater than, I flip the sign, 2 is greater than x. So that's part of it, okay? And I'm actually going to erase this so I give myself more room. So in this next inequality, negative 2x plus 1 is less than or equal to 9. Same set of steps, subtract 1, negative 2x is less than or equal to 8. I divide both sides by negative 2. That means, got to remember, you got to flip the sign. So x is greater than or equal to negative 4. So you got to be careful with this inequality. You got to remember with and inequalities, the lesser number goes on the left, our variable goes in the middle, and the greater number goes on the right. This means all numbers between negative 4 and 2, including negative 4. So I graph those 2 points, only fill in the negative 4, and shade to the middle. So and inequalities are a little more tricky because you have to know how to rewrite them as 2 separate inequalities. Or inequalities, on the other hand, are a little, I think, simpler to write because they're already separated. So I can rewrite these more easily as 2 separate inequalities to solve. So in this example, I'm solving this or inequality and graphing the solution. To solve this, I would add 5 to both sides. 3y is less than negative 3. If I divide both sides by 3, y is less than negative 1. And the reason I didn't flip the sign there is because I didn't divide by a negative value. I divided by a positive value. So my next inequality, I add 1 to both sides. 2y is greater than 6. Divide by 2. Y is greater than 3. Y is greater than 3. So first I'll write it as my or inequality. Y is less than negative 1, or y is greater than 3. I'll make that a little bit straighter. Well, not really. So I've got a point at negative 1, a point at 3. I have 2 open circles. I'm going to shade to the left of negative 1, and then I'm going to shade to the right of 3 to show my solutions. So, guided practice. I am really just going to let you guys work through these, and then I am just going to show my solutions, okay? I'm not really going to explain, but I'll show my solutions and show my work. I'll flash that on the screen, give you a chance to pause the video, work through them, pause the video and check your solutions, and then I'll finish example 4. Okay, so I'm going to give you a second. You may want to pause the video just to look these over. I'm going to zoom out a little bit, actually, to show you all of them. So if you want to pause the video to see your solutions and check them, I'm going to move on to example 4 in a second just to keep moving along here, but double check your solutions, ask questions if you're not sure on any of them, or if you think I may have made a mistake, but double check to see that you're working to be more independent with solving some of these problems. So in the last example, it talks about electrical devices that operate effectively within a specified temperature range. So it can be too cold or too hot for the iPhone, iPad, whatever device it is to operate properly. So we're going to write a compound inequality. This is an actual diagram from Apple. We're going to write a compound inequality representing the operating temperatures, okay, for these. So what I'm going to say is we're going to go by the actual diagram here, the 32 degrees and the 95 degrees. So I would say a compound inequality for this in Fahrenheit for these devices, it's going to be temperatures between 32 and 95. So it's going to be an and inequality. So I'm going to write this as 32 is less than or equal to, and let's just use T for temperature. Okay? Because once it gets below 32 degrees, it's too cold for it to operate. Once it goes above 95 degrees, it would be too hot to operate. So in part B, it says describe one situation in which surrounding temperature could be below the operating range and one which could be above. And I've got two situations that are really similar. Too low. Maybe it was left in a car during winter. Let's say it was 20 degrees outside. That might cause your iPhone not to work properly. Too hot. Sitting by a window, let's say, on a hot day with the sun beating down in it. You know? And maybe it was a hot day and the temperature was 100 degrees. So it's just thinking about situations where you think about compound inequalities. You think about the concept of them. You don't actually write them, but you use them to understand when is my iPad going to be okay to work, or when is my iPhone going to be okay to work. So generally, when we talk about ranges, it's an and inequality, okay? It's an and inequality generally when we talk about a range of values. So this is a good chance for you to move on to the next part of the lesson and keep practicing this, and the solving is the thing that I want you to really try to nail down.